Welcome back all of you. Today we are going to solve the half yearly examination paper of Maths class 9th. Okay. So we will start from the first question from section A. The first question from section A was, can we write half yearly paper 2020-21. Okay, maths half yearly paper. Okay, so the first question is can we write 0 in the form of P upon Q? Okay, first question is, can we write 0 in the form of P upon Q dash? The answer is yes, we can write 0 in the form of P upon Q, because you can write 0 as 0 upon A. You can write 0 is equal to 0 upon A, where A is not equal to 0. Therefore, this is equivalent to P upon Q. Hence, it can be written in the form of P upon Q. Therefore, we can write 0 in the form of P upon Q. Okay. Next question. Next question is, every rational number is dash. Question number 2. Every rational number is dash. The answer is real number. The answer is real number. Every rational number is a real number. Okay. Third question. We will discuss this question afterwards. Coming to the fourth question. Root 6 into root 27. Root 6 into root 27. Then we can solve this. We can factorize root 6. Root 6 can be written as root 3 into root 2. And root 27 can be written as 3 into 3 into 3. Therefore, this will be equal to one pair, second pair. 3 into 3 root 2. This is equal to 9 root 2. Okay. Next question. Question number 5. X minus x cube is a dash polynomial. Is a dash polynomial. The answer is cubic polynomial. The answer is cubic polynomial because the degree in this equation, the degree of x in this equation is 3. Therefore, this will be a cubic polynomial equation. Next, question number 6. 1 plus 3x is a dash polynomial. The answer is linear. Why the answer is linear? Because the degree of x is here 1. Therefore, this equation is a linear polynomial. 7. If x coordinate x coordinate of a point, if x coordinate of a point is, if x coordinate of a point is 0, then it lies on dash axis. Okay, so we know very well that on a coordinate axis we have two axes. This is y axis, this is x axis. Any point on the x axis, any point on the x axis will have y coordinate 0, and any point on the y axis will have the x coordinate 0. Okay, therefore as per our question, if x coordinate of a point is 0, okay, then it lies on dash axis. X is 0, that means it will lie on y axis. It will lie on y axis. Next question. Question number 8. In the equation y is equal to mx plus c, okay, where m is dash. So you can say in this equation m is constant. You can say m is constant, but actually what m represents? The m represents the slope. The m represents the slope, because y is equal to mx plus c. You can write y minus c is equal to mx, and this can be simplified as y upon x minus c upon x, okay, is equal to m. Okay, so you can say this represents slope. Okay, this represents slope of a line. Okay, next question. An acute angle, question number 9. Our next question is question number 9. What is the question number 9? An acute angle is dash than 90 degree. We know very well that acute angle will always be less than 90 degree. Okay, an angle greater than 90 degree, an angle greater than 90 degree, an angle greater than 90 degree, an angle less than 90 degree. The angle which is less than 90 degree is known as acute angle. The angle which is less than 90 is known as acute angle. Okay. Now next question. Question number 10. A reflex angle is dash. A reflex angle is dash than 90 degree. We know very well that reflex angle is always greater than 90 degree. Okay, reflex angle is always more than 90 degree. Okay, next question is question number 11. What question number 11 asks? Question number 11. Question number 11 says, if x is equal to 1, y is equal to 2, then the value of k, then the value of k for equation, then the value of k for equation 2x plus 3y is equal to k. Okay, put the value of x and y, put the value of x and y in this equation. You can say 2, the value of x is 1, so 2 into 1 plus 3, the value of y is 2, 3 into 2 is equal to k. You can write this 2 plus 6, okay, and is equal to k. Therefore, k is equal to 8, okay. So, this was the question till question number 11, okay. Now, further we will solve. Now, further we will solve the questions. Okay, we are moving ahead and solving the next question. Question number 12. How many solutions? Question number 12. How many solution has equation 3y is equal to kx plus 7 . How many solution has equation 3x plus ky plus 7? Okay, the answer is many solution. The answer is many solution. Okay, because we will, if we start putting the value of x in, if we will start putting the value of x in this equation, we will get the different values of y. So for every value of x, we will get a different value of y. Therefore, we can say that we will get a number of solutions for this equation. Okay. Now, question number 13. A point 3, 4 lies on the graph. A point 3, 4 lies on the graph of the equation 3y is equal to kx plus 7. The value of k. In this question, it is actually asking the value of k for the point 3, 4. We know very well that if any line is passing from any point, or if any point is lying on any line, then both the coordinates of that point will satisfy that equation of line. That means on putting the value of x and y in that equation, we will get what? We will get 0. Putting over here, point 3, 3y is equal to kx plus 7. Okay. So, y की value for kx is 3 plus 7. 4 3 is 12 is equal to 3k plus 7. Okay. Now, taking everything on one side, then 3k plus 7 minus 12 is equal to 0. Equating to equal to 0. Therefore, 3k minus 5 is equal to 0. Therefore, k is equal to 5 upon 3. Okay. That means if this point 3, 4 will lie on that line which is having the equation as 3y is equal to kx plus 7, then the value of k for that equation will be is equal to 5 upon 3. Next question, question number 14. The graph of the equation, the graph of the equation, the graph of the equation, sorry, the graph of the linear equation, the graph of the linear equation x plus 2y is equal to 2 cuts the y-axis, cuts the y-axis at dash. So we know very well, if any line cut the y-axis, then at that point the value of x coordinate will be equal to 0. Okay? Therefore, x plus 2y is equal to 2, and we know very well, if any line cuts the y-axis, then its x coordinate will be 0. Therefore, putting the value of x is equal to 0, 2y is equal to 2, therefore y is equal to 1. Okay? Therefore the point will be x is equal to 0 and y is equal to 1. Okay? This will be that point when this line will cut the y-axis. Okay? Next, if the coordinates of point, next question is 15, if the coordinates of a point, if the coordinates of a point are 0, minus 4, then it lies on dash axis. Okay, we know very well that on x-axis, we know very well that on, this is y-axis, this is x-axis. On x-axis, the value of y is 0, and on y-axis, the value of x is 0. You can see over here, the x coordinate is 0. The x coordinate is 0, that means that point will lie on the y-axis. Okay, that point will lie on the y-axis. Okay. Now, question number 16. Question number 16 is, the zero of a polynomial, the zero of a polynomial, the zero of a polynomial fx is equal to 2x plus 7 is what? Okay. We know, to find the zero of a polynomial, we will have to equate that equation equal to 0. Okay. Therefore, fx is equal to 0. Therefore, fx is equal to 2x plus 7 is equal to 0. Therefore, 2x is equal to minus 7. Therefore, x is equal to minus 7 upon 2. Okay. So, we will get the zero of the polynomial at x is equal to minus 7 upon 2. Okay. We will get the polynomial 0 at x is equal to minus 7 upon 2. Now, this was the question number 16. We are having 3 more questions in section number A, which we will solve further. Okay. Now, rubbing all this, coming back to our questions. Now, question number, I think 17. Question number 17. What is question number 17 is, the value of fx, the value of fx is equal to 5x minus 4x square plus 3 when x is equal to minus 1. Okay, so we will have to find the value of fx. Okay, we know that to find the value of fx we have to put x is equal to minus 1 in that equation, then we will get the value of fx. So fx is equal to 5x minus 4x square plus 3. Putting x is equal to minus 1, we have 5 into minus 1 minus 4 into minus 1 square plus 3. Then this is minus 5, this is 4, this is 3. This is minus 9 plus 3 and this is equal to minus 6. So the value of f minus 1 is equal to minus 6. Okay. Now next question. Question number 18. Question number 18 is 3 root 6 plus 4 root 6 is equal to what? Okay. 3 root 6 and 4 root 6. You can see over here what is common in both the terms. Root 6 is also here, root 6 is also here. Take root 6 as common. Take root 6 as common. What we get over here? 3. What we get over here? 4. 3 plus 4 is 7. So this is 7 into, so this is root 6 into 7 and this can be written as 7 root 6. Okay. So the addition of 3 root 6 plus 4 root 6 will be equal to 7 root 6. Now question number 19. Which of the following is irrational? Root 16, root 12, 13, root 12 irrational. So question number 19. Which of the following is irrational? Okay, options are A, root 16, which can be written as 4. Option B, root 12 upon 3, which can be written as root 4, which can be written as 2. Option C, root 12, which can be written as 2 root 3. Option number D, root 100, which can be written as 10. So you can see over here this number root 16, root 12 by 3 and root 10, they are a perfect square. Okay, they are a perfect square. The only number which is not a perfect square is option number C, 12, 2 root 13, 2 root 3 and 2 root 3 is an irrational number. Okay, so the correct option is root 2 root 3, optional number C. Okay, next question. Section B. Section A is over. Now section A is over. Now we are going to start the section number section B. The first question of section B is solve each of the following. Solve each of the following using suitable identity. Okay, using suitable identity. A, x plus 2y plus 4z whole square. B, 2x minus y plus z whole square. Okay, so So solving the first one, x plus 2y plus 4z whole square. We know a plus b plus c. We know a plus b plus c whole square is equal to a square plus b square plus c square plus 2 bracket ab plus bc plus ca. Similarly, solving this, a is equal to x square, b is equal to 2y square, c is equal to 4z square plus 2 bracket ab 2xy bc 8yz ca 4xz. Okay, solving further, we get x square plus 4y square plus 16z square plus 4xy plus 16yz plus 8xz. Okay, so anything wrong is over here? A square b square c square to ab 2xy bc 8yz ca 4zx. On solving 2 to the 4, 8 to the 16 and 4 to the 8. Okay. Now second part, 2x minus y plus z whole square. Same formula, same concept. Okay, let's do it. A square plus b square plus c square plus 2ab 2xy plus bc plus ca. Solving further, 4x square plus y square plus z square minus 4xy minus 2yz plus 4xz. Okay, so this was the solution of this question. Next question is missing from my paper, question number 2, and I will find the solution of this question. First of all, I will find this question because I don't have that question number 2 in my notebook, so that's why I am not able to solve that question. I will do it later on. So we are moving to the next question, question number 3. Okay, question number 3. What is question number 3? Question number 3 is find the value of k. Question 3 is find the value of k if x minus 1 is a factor of px where px is equal to kx square root 2x plus 1. Okay, so solving this question, we have px is equal to kx square root 2x plus 1 and x minus 1 is its factor. Okay, therefore x minus 1 is equal to 0 x is equal to 1. Okay, putting the value of x is equal to 1 in px, putting the value of x is equal to 1 in px, therefore p1 is equal to k minus root 2 plus 1. Okay, this is equal to is equal to 0. Therefore k is equal to root 2 minus 1. Okay, we get k is equal to root 2 minus 1. Okay, if x minus 1 is its factor, then we will put the value of x is equal to 1 in that equation px, and we will equate that equation equal to 0. Then we will get the value of k. Now next question, question number 4. Evaluate the following. Evaluate the following. Question number 4. Question number 4. Evaluate the following. Evaluate the following without multiplying. Evaluate the following without multiplying. A 103 into 107. B 95 into 96. Okay, we have to solve this question without actual multiplying. Okay, we have to solve this question without actual multiplying. Okay, we have to solve this question without actual multiplying. Okay, so solving first. A is equal to 103 into 107. We can write this as 100 plus 3 into 100 plus 7. Okay, using the formula x plus a into x plus b is equal to x square plus a plus b into x plus ab. Okay, using the formula x plus a into x plus b is equal to x square plus a plus bx plus ab. Here the value of x is 100, therefore 100 square 3 plus 7 into 100 plus 21. This is 10,000. This is 1,000, and this is 21. 1 2 0 0 1. We will get we will get 1 1 0 2 1. Okay, now next question. B 95 into 96. So this can be written as 90 plus 5 into 90 plus 6. The same formula has to be used over here. Therefore a square plus 5 plus 6 a plus b into x 90 plus ab 5 into 6. 90 square 8,100. 5 6 11 into 9 99 990 plus 30. Okay, on adding, add 8100 990 30 0 12 11 9120. Okay, what we get? We get 9120. 0 as answer. Okay. Now solving the next question, question number 5. Solving the next question, question number 5. The question number 5 is find 6 rational number between 3 and 4. Question number 5 is find 3 rational number. Question number 5 is find 6 rational number between 3 and 4. Okay. So we have to find we have to find 6 rational number. Okay. So n is equal to x plus 1. Here the value of x is 6 plus 1. N is equal to 7. Where why we are using x is equal to 6? Because we have to find 6 rational numbers between 3 and 4. We get n is equal to 6. Now x is equal to 6, then n is equal to 7. Therefore 3 into 7 upon 7. 4 into 7 upon 7. This will equal to 21 upon 7. This is equal to 28 upon 7. So the 6 rational numbers between these two will be 22 upon 7, 23 upon 7, 24 upon 7, 25 upon 7, 26 upon 7, 27 upon 7. 1, 2, 3, 4, 5, 6. So these are the 6 rational numbers between 3 and 4. Okay. Now next question. Our next question is represent the root 3 on a number line. Our next question is represent root 3 on a number line. We have to represent the root 3 on a number line. This is a very geometrical question. This is a very good geometrical question, and for solving this question we need pencil, rubber, scale, protractor, compass. There are different geometrical instruments we need for solving this question. Okay, but I am going to do this question simply by my marker, and my is board. So it will be a little bit difficult for you to understand, but try to understand as much as you can. Okay. So first of all, we will draw a number line. Okay. Suppose this point is O, this point is A, this point is B, and this point is C. Okay. This is a number line. Take OA is equal to 1 centimeter. Okay, take OA is equal to 1 centimeter. Okay, so this is OA 1 centimeter. Okay, this is OA 1 centimeter. Okay, now draw a perpendicular line. Okay, now draw a perpendicular line at A of 1 centimeter. Okay, from point A, draw 1 centimeter line in upward direction. Suppose this point as B. Okay, now connect point O and D. Connect the point O and D. We get a right angle triangle OAD. Okay, this is also one unit. Okay, Now we know very well that in a right angle triangle, hypotenuse square is equal to base square is equal to plus altitude square. Okay, we know this very well. Okay, the hypotenuse is OD, base is OA, and altitude is AD square. OD is square is equal to OA square, 1 square, plus AD square, 1 square. 1 square 1 plus 1, 1, 2. Therefore, OD is equal to root 2. We get the value of OD. We get the value of OD as root 2. Okay. Now, next step. Draw a line of 1 centimeter at point B in perpendicular direction. Okay, in perpendicular direction. So the perpendicular direction will be like that. Okay, we get, name this point as E. Okay, name this point as E. Okay, now connect point O and E. Connect the point O and E. Okay. Now, in triangle OED, OE square is equal to OD square plus ED square. Okay. The value of OD is root 2 square. The value of ED is 1 unit. The value of ED is 1 unit. 1 square, root 2 square, 2 root 1 square, 1 is equal to 3. Therefore, OE is equal to root 3. So, we get the value of OE as root 3. Now, we have to represent root 3 on a number line. We get, now, to represent the root 3 on number line, take OE as equal to radius. Take OE is equal to radius and draw a complete circle. Okay, this is radius, draw a circle. Suppose this point, the circle cuts the horizontal line or number line at here. This point is F. So the distance from O to F, the distance from O to F will be equal to root 3. Okay. So like this we will represent the root 3 on the number line. Okay. Now next question. Our next question is visualize. Our next question is visualize. Our next question is visualize 3.765 on a number line using successive magnification. Okay. Our next question is visualize 3.765 on a number line. Okay. Our next question is visualize 3.765 on a number line. Okay, visualize a number line using successive magnification. Okay, using successive magnification. So first, draw a line. Okay, draw a line and divide it in equal to 10 parts. This is O 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this is O, this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9, and this is 10. Okay. What was our point? 3.765. So first we will find out 3.7. We will find out 3.7. First we will find this point 3.7. So take this line point 3 and 4. 3 and 4 and connect it. This is point 3 and again divide this line into 10 equal parts. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Suppose this is not 10 here, this is 10 here. Okay. Now we have to point 3.7. So this is 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7. So our point 3.7 is over here and this is 3.8. Okay, this is 3.8. Take these 2 points. Take these 2 points. Okay. Now this point is 3.7 and this point is 3.8. Now again divide this line into 10 equal parts. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So this is 3.71, 3.72, 3.73, 3.74, 3.75. We have to find 3.76. So this is 3.76. Okay, this is 3.76, and this point is 3.77. Okay. To take these 2 points. Okay, 3.76 and 3.77. Again, connect these 2 lines, these 2 points. Okay, and again divide this line into 10 equal parts. This point will be 3.76 and this is 3.77. So this is 3.1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So this is 3.76, this is 3.77, this is 3.7, sorry, this is 3.76, this is 3.761, this is 3.762, this is 3.763, this is 3.764, this is 3.765. So we have to get the 3.765. So here is point 3.765. Okay. So in this method, you have to draw that point on the number line. Okay, what we did? We took the point 3 and the next point is 4. We draw the line from 1 to 10, choosing those 2.3 and 4. Now, magnifying the points between 3 and 4 as 3.1 to 3.9, choosing 3.7. Again, the next point will be 3.8. Magnifying 3.7 and 3.8 into 10 equal parts, we get 3.76. Next point will be 3.77. Again, magnifying 3.76 and 3.77 into 10 equal parts. So we get what? 3.761, 3.762, 3.763, 3.764, 3.765. That point, that was the point which we have to find out. Okay. So in this way, we solve this question. Okay. Now our next question. Our next question is from section C. Okay. Section B is over, and we are going to solve the question from section number C. Okay. We are going to solve the problems from section number C. So what is the first question from section number C? The first question from section number C is the first question from section number C. Okay, section C. The first question from section number C is in the given figure angle PQR is equal to angle PRQ, then prove that angle PRT is equal to angle PQS. Okay, the figure is over here. This is a triangle extending these points in both directions. This point is P, this point is Q, this point is R, this is T, this is S. So what is given in our question, that angle PQR is equal to angle PRQ. Angle PRQ. Suppose this angle is X. Okay, this angle is X. So we will find this angle and this angle. Okay. We know ST is a straight line. Okay, we know that ST is a straight line. So angle SQP plus angle PQR is equal to 180. So angle SQP plus angle PQR, this is X, is equal to 180. So angle SQP is equal to 180 minus X. Okay, this is first. Similarly, angle PRT plus angle PRQ is equal to 180. Okay, straight line 180. Angle PRT plus angle PRQ X is equal to 180. So angle PRT is equal to 180 minus X. Suppose this is 2. So you can see from 1 and 2, angle PRT is equal to angle SQP is equal to 180 minus X. Okay. So here, from here we can see that we proved what we have to prove. Okay. Both the angles are equal and they are equal to 180 minus X. Okay. Now this question is over. Next question, question number 2. The cost. Our next question. Our question number 2 is the cost of a pen. The cost of a pen, sorry, not pen, notebook. The cost of a notebook is twice the cost of pen. Okay. Full stop. Write the linear equation. Write the linear equation in variable to represent and draw graph. Okay. So we have to find a linear equation for a question in which the cost of notebook is twice the cost of pen. Okay, suppose cost of pen be rupees X. Therefore, cost of notebook is twice the cost of pen. Therefore, 2 into X is equal to Y. Y is equal to 2X. Okay. So, this is the equation for this question. Now we have to draw the graph. So for that we will tabulate. We will tabulate here. This is X, this is Y. Tabulate. X is equal to 0, 1, 2, 3 and 4. For different value of X we will get a different value of Y. If we put the value of X is equal to 0 over here, we get the Y is equal to 0. X is equal to 1, Y is equal to 2. X is equal to 3, Y is equal to X is equal to 2, Y is equal to 4. X is equal to 3, Y is equal to 6. X is equal to 4, Y is equal to 8. So, if you will draw the graph, this is X, this is Y. Okay. So, this is 0, this is 1, this is 2, this is 3, and this is 4. 3, 2, 1. On y-axis 0, 2, 4, 6 and 8. This is 8, this is 6, this is 4 and this is 2. One more thing, on y-axis 1 unit, 2 unit is equal to 10 division. On x-axis 1 unit is equal to 10 division. Why I am telling you that? Because on graph paper every 1 unit has 10 divisions. Here 10 division is equal to 2 unit, because you can say 2 difference is 2, 0, 2, 4, 6, 8. The difference is 2. On this x-axis the difference is 1. So on x-axis 1 unit 10 division, on y-axis 2 unit 10 division. Okay. Now plot those points. At x is equal to 0, y is equal to 0. This point at x is equal to 1, y is equal to 2. At x is equal to 1, y is equal to 2. At x is equal to 2, y is equal to 4. At x is equal to 3, y is equal to 6. At x is equal to 4, y is equal to 8. So we get all those points. This point, this is this and this. Connect all those points similarly. Okay? Connect all these points. If you connect all these points, then you will get a straight line. Okay? Linear equation, straight line. Okay? So this was the graph of the equation y is equal to 2x. Okay? Now next question. Question number 3rd of section number C. What is question number 3rd of section number C? The question number 3rd of section number C is find the value of k. Find the value of k find the value of k if x is equal to 2. Okay. Question number 3. Find the value of k if x is equal to 2 and y is equal to 1 is a solution of 2x plus 3y is equal to k. This is a very easy question. Okay, you can solve. You can see over here 2x plus 3y is equal to a. Put the value of x and y in this equation. Therefore 2x is equal to 2 plus 3y is equal to 1 is equal to k. Therefore k is equal to 4 plus 3. K is equal to 7. Nothing was new in this question. This was a very simple question. Okay. Now next question. Question number 4. Question number 4. What is question number 4? The question number 4 says if the point 3, 4 lies on the graph, if the point 3, 4 lies on the graph of equation 3y is equal to ax plus 7, find value of a. Okay, so 3y is equal to ax plus 7. The point 3 and 4, the point 3, 4 lies on this equation. Therefore, what we will do, we will put the point 3 and 4 in this equation and equate it equal to 0. Therefore, 3y minus ax minus 7 is equal to 0. 3, the value of y is 4 minus a, the value of x is equal to 3 minus 7 is equal to 0. 3 4 is 12 minus 3a minus 7 is equal to 0. Therefore 5 minus 3a is equal to 0. Therefore a is equal to 3a is equal to 5. Therefore a is equal to 5 upon 3. Okay. You get the value of a is equal to 5 upon 3. Now next question. Question number 6. Question number 6. Factorize each of the following. Okay. 27 y cube plus 125 z cube. Next 64 m cube minus 343 n cube. Okay. Now first A is 27 y cube plus 125 z cube. You can write this as 3y cube plus 5z cube. Okay, the cube of 3 is 27, the cube of 5 is 125. Okay, simple. Now this is using the formula a cube plus b cube is equal to a plus b bracket a square plus b square minus ab. Therefore 3y cube plus 5z cube, sorry 3y plus 5z 3y square plus 5z square minus 3y into 5z. You can write 3y plus 5z, this is 9y square, this is 25z square, and this is 15yz. Okay. Similarly, the second one 64 m cube minus 343 m cube. Okay, this is 4 m cube. This is 749. 7. This is 7 n k cube. So formula is a minus b, a square plus b square plus ab is equal to a cube minus b cube. Okay, so this is 4m minus 7m, 4m square plus 7m square plus 4m 7m. Okay, so 4m minus 7m 16m square plus 49m square plus 28mm. Okay, so this was the solution of this question. Okay, now solving the next. Now solving the next question. Question number 7. Question is rationalize 1 upon 5, 1 upon root 5 plus root 2. We have to rationalize this question. We have to rationalize this number. Okay, so 1 upon root 5 plus root 2 multiply in the numerator and multiply in the numerator and in the denominator by the same number but different sign in the middle. So this will root 5 minus root 2 upon root 5 minus root 2. Okay, so this is root 5 minus root 2 upon root 5 square minus root 2 square. This is root 5 minus root 2 upon 5 minus 2. Therefore root 5 minus root 2 upon 3. Answer. Okay, this was a simple question. Next question from section D. Okay, next question from section D. What is the first question? Find 5 rational number. Find 5 rational number between 3 by 5 and 4 by 5. Okay, we have to find 5 rational numbers. Okay, so we know n is equal to x plus 1. The value of x is 5. 5 plus 1, n is equal to 6. Okay, so we will multiply in the numerator and denominator by 6. Okay, so 3 by 5 and 4 by 5 into 6 into 6 into 6 into 6. Then this is equal to 6 is 18 upon 30. This is 24 upon 30. So the 5 rational numbers will be 19 upon 30, 20 upon 30, 21 upon 30, 22 upon 30, 23 upon 30. Okay, from 18, start from 18 and move up to 24. So we get the 5 rational numbers in